Hello students, welcome back. So in this session, I'm going to be covering data types. So the topics that I'll be covering would be the types of data type, the size of the data type, and how do you change your data type from one type to the other types. Few things about your data type. Number one, every NumPy array will contain the elements of the same data type. You're not going to have mixed data types. Second, your NumPy, when you create your NumPy array, it's going to try to guess what type of data type you have when you create an array. Also, it gives you the option to explicitly specify the data type. And I'll show you in a minute how it does that. And also, NumPy has a huge feature of data types. So let's go through each one of them. So there's an integer data type. Let's start with integer data type. Integer, again, is of two kinds, unsigned integer types, and then you have signed integer types. Unsigned integer types, they refer to your numeric data types that can only represent positive numbers. Okay, in other words, they can only represent your negative numbers. That's all. Sorry, non-negative numbers. So let's look at this one right here. Okay, this is telling me that this is my NP unsigned int 16. Okay, U stands for unsigned. 16 refers to the bits. Okay, 16 bits. Now this one can hold the numbers from 0 to 65,535. So as you can see, as your bits goes up, the number it can hold, the range of number it can hold, it actually goes up. It goes higher. Okay, signed integer. Now this one contains positive and negative integers. Okay. Now let's look at this one right here. Okay, this one right there. This one is np int 16. It's a 16 bit. Okay, that's what the 16 refers to. And this can hold from minus 32 768 all the way to 32,767 value. Okay, so this is the minimum to maximum. So this is your range of value it can hold. Then you have floats data type. So you have float 16, you have float 32, and float 64. So let's look at float 64. What it says, this actually controls your precision. Precision, if you remember, refers to your decimal values. Okay, how many points, how many numbers you're going to have after your decimal point. So in this case, if let's say you want 15 decimal digits, or let's say 15 or somewhere around 15, you want to go with float 64. Okay, that's going to have 64 bits. Then you have complex numbers. Complex numbers has real and imaginary parts. So let's look at this first one. This is complex 64. This is going to have real and imaginary. Now both going to hold float 32. So this is going to be 32 plus 32 bit. So 32 bit plus 32 bit is 64 bit. All right. Boolean data type. Now this actually is used when you know your data is always is only going to contain true or false. Okay, so this is where you want to use Boolean. All right, then you have text and string data type. So this is your string data type, and Unicode, bytes, and object, and so on and so forth. Then you also have data type for your date time and your time delta. This is for differences. Sometimes you want to calculate the difference between two dates or between two times. So this is your time data. All right, now as you see, we have so many types of data types in your NumPy. Why do we even need so many data types? Well, number one, memory efficiency. So different data type, they require different amount of memory. For example, your int 8 uses 1 byte, int 64 uses 8 byte. So by choosing the right type of data type, you save memory. That's the very important thing. And especially it becomes very important when you're working with large data sets. Performance. Now, when you are doing operations or numerical computation on smaller data types, they tend to be a lot faster. Okay, so this is very important too. So you want to have a smaller data type if you know that that all your numbers going to fit in that data type. Precisions. Sometimes different data types, they occupy different levels of precision. So for example, float 32 has less precision than float 64. So this is where you actually make a decision. You make a decision based on memory efficiency, based on performance, and based on precision. All right, so these are some of the guidelines for choosing number data types. So what kind of data do you have? You ask yourself this question. If it's a whole number, if it's an integer, then you're going to use int 8, int 16, int 32, or int 64, depending on the range, okay? If it's a decimal, if your numbers are decimal, you're going to use float 32 or float 64, again, depending on the range. If it's a true and false value, you're going to use Boolean. If it's a text or categorical labels, okay, then use your str or object, okay? Now, for example, if you know your data is ages, okay, you have ages and you know the age is going to be from between 0 to 120, then it's a good idea to use this one, np.uint8. Okay. Likewise, if you know your data is population counts, which is in millions, then it's a good idea to use np.int32. That tends to be safer. And in case if you're dealing with financial values, let's say billions and billions of dollars, then use np.float64. All right, so let's get started. Let's get some hands-on training. So I take this thing, come over here and create another cell. All right, actually, let me create a few more cells. All right, paste it. So in this case, I'm creating a NumPy array, 1, 2, 3, 1, 2, 5, 2, okay? And then I print my x.data type. All right, and then I'm also creating another NumPy array right here, okay? And I'm also printing its data type. And as you can see, this one, okay, this one right here, okay, it printed my data type as int32 because NumPy guessed that this one is int32. This one over here, okay, this one when I create my NumPy array and I print my data type, it printed float 64. NumPy guessed by looking at these decimal numbers that this is a float. Okay, now let's force a particular data type to an integer. We can do that. So let's say this is your array, okay, 1252, and you want to force it to integer 8. Now before, by default, it was initialized to integer 32, but you want to force it to int 8. You can do that too by using this argument, dtype equal to np.int8, and then when I print my data type, it prints out integer 8. Okay, now let's check how big and small your values can actually get. In other words, you want to check your range, like how many, what type of range of values it can hold. So what you can do is you can use this inbuilt method called iinfo. I refers to integer. So if I run this and you can see the machine parameters for integer 8, it tells me the minimum value it can hold is minus 128 and the maximum value it can hold is 127. All right, so you can do each one of them. You can comment out each one of them and just try to see what it prints. Okay, so let's go to this one and let's run this, and you can see the number actually goes up. So as your bits goes up, okay, you're from 8 to 16 to 32 to 64. As your bits goes up, your numbers also goes up, minimum to maximum. It goes up. Okay, let's try to see some of the data types that we have in NumPy. Let's try to study some of them. So come over here, paste it, and let's run this cell. All right. So in integer data type, you have int 8, int 16, int 32, int 64, right? So over here, I'm creating an array, and the data type I'm giving is int 8. All right, and I'm printing my integer array, which I printed out over here, and I print my data type. And as you can see, it prints out my data type right here. By the way, you can do the same thing with the rest of the other integer data types. Okay, same thing with the unsigned integer. You can also do the same thing with unsigned integer. So come over here, run this cell, and everything is exactly same. This time I'm just choosing a different data type. I'm choosing uint8. All right, and you can choose any one of these. All right, complex data types. You can also choose from the complex data type. Oh, sorry, float. You can also choose from the float. So you have float right here. Okay, let's run this. All right. So in this case, you have three options: float 16, float 32, and float 64. Choose the one that you want. I'm choosing float 64, and as you can see, it prints out float 64, my data type. All right. You can even choose your complex. All right. Come over here and complex. So again, in complex, you have two kinds: complex 64, complex 128. Okay. And I'm printing my complex array, and I'm also printing my data type for my complex. And as you can see, it prints out complex 64 because I choose complex 64 over here. Okay, and then of course you have Boolean. All right, you have Boolean. These are your Boolean right here: true, false, true, false. If you know your value is going to be true, false, true, false, so make sure this is Boolean. Okay, it'll make your life. It's going to hold just the right amount of space. All right, and as you can see, it's a Boolean. Okay, if you know that your data type, if you know that your data type is going to be string, okay, then it's a good idea to choose string. All right, so in this case, I have a data type right there, my a equal to this right there. Okay, this is my NumPy array, these are my elements, and then my data type is, I'm choosing it to be string. You actually call str underscore over here, and I print my data type, and it prints out my data type. This is a symbol for string. All right, now if you know your array Okay, it's going to hold a mixed kind. Let's say, not sorry, not the array, but your element is going to be like integer, string, and a float. Then it's a good idea to use a NumPy array and put the NumPy array type, data type, as object underscore. All right, and now if I run this, it's going to print my data type at the end, and as you can see, it's object. So it's going to treat the whole thing as an object. All right. Now, size of data type. Sometimes you want to see what type of size your data type is, okay? Or what is the size of your data type? You can do that too. So let's come down. Let's open a few cells and come down and paste it over here. So let's say you want to check the size of your int 8 or size of int 16. So these are the commands. These are the syntax you can use to find the size of each one of them. So let's look at this one. Size of int 32 is 4 bytes, okay? And as you can see, that as your bits goes up, your bytes also goes up. So 8 bits makes 1 byte, 16 bits makes 2 byte, 32 bits is going to make 4 byte. Likewise, you can do the same thing for unsigned integer. All right, unsigned integer. Come over here. So this is my unsigned integer right here. Okay, if I run this cell, it's going to give me all my space right there. Okay, what is the size of that? So if you look at this one right here, last one, this one is 8 bytes. Okay, because 64 bits turns makes 8 bytes. 8 times 8 is 64. All right. You can also see float. Okay, you can also see float data types. So if you run this, it's going to give you float 16 is 2 byte, float 32 is 4 bytes. Okay, float 64 is 8 bytes. Okay, and then of course you have Boolean and object type. So come down, let me run this. So size of Boolean, if I run this, it's going to give me 1 byte. Okay, as you can see, it gave me 1 byte, and the size of object is 8 byte. All right, so this is telling you that the size of each object is going to be 8 byte. Okay, now how do you change data type? So there is a method, inbuilt method called as type. Okay, that's the method you use to change your data type. Now remember, your as type is always going to return a new array. Okay, this is important. So it's not going to change in place, it will return a new array. Okay, so changing data type to uint. So let's say this is my NumPy array. I create my NumPy array, I print my original, right? Let me just, yeah. I create my NumPy array, then I print my original right here, and then I print my data type. So as you can see, this is my original, and my data type is int32. And then I'm saying a equal to a int, a equal to a dot as type. I'm calling this inbuilt method as type, and I'm specifying that, saying that, hey, change it to np.uint8. Okay, and then when I run this, you can see it prints out a new array. Okay, I'm printing my new array right there, and then I'm also printing my new data type, what that is now. And as you can see, it has changed to uint8 because I changed it over here. Likewise, you can change the rest of them too, because you can come over here, you can run this, it's going to change it to float. So when I print this right here, okay, it prints out to float because I changed it to float over there. And likewise, you can change the rest of them. Okay, you can have this float 32. If you run this, it's going to give you float 32, as you can see. And if you want to change to str, you can change to str too. So if you run this, and there you go, you see that it changed it to str. So it took these numbers, okay, all these numbers, and it converted it into string. And as you can see, there's a string right there. It says in quotes. Okay, and then let's go back over here, run this again. All right, now changing data type, okay, from float to integer. I wonder what happens over there. Well, remember, you have float values. So these are your float values. If you try to change a float, okay, this is my, let me run this. So these are my original array. I print my original array and print my data type. So my original array is this right here. My data type is right here. And I'm trying to change it to an integer. Okay, so I print my new array and I print my data type. And as you can see, your new array is 1, 2, 3, and your data type is int32. So all the fraction part, all the numbers after the decimal, they're gone. Okay, now changing data type from string. Maybe you want to change from string to integer. Can you do that? And the answer is yes, you can. So this is my NumPy array, right? And as you can see, every single element is string. Okay, but every number that's inside the string is a number, or every element present inside the string is a number. So I'm printing my original. Okay, it prints out my original right there. I print my data type. It prints out my data type. All right, and then I print my new array again. It prints out my number right there, and then I print my data type. it prints out int32. And as you can see, look at this. This is in quotes, right? So this is a string, but now it has turned into a number. So I use this command, this inbuilt method, as type int, and that converted into from your numeric from your string to your integer. All right, gentlemen. Thank you.